Well, welcome back to the Crazy Hill household, where you'll hear all sorts of weird things during these videos. So, welcome back, and our topic today is integration of natural logs. So I think before we dive in, we'll probably should start by reviewing the derivative of natural logs. So the derivative of the ln of x, hopefully you remember, is 1 over x. And we said we have a more general rule when we have the derivative of a natural log, and that's what, putting it in terms of u. So if I say the derivative of the ln of u, hopefully your mind is thinking du over u. All right, and that's kind of been our method we've used throughout the course here. When you see ln's, you're thinking du over u. So let's just kind of do one quick example, and we'll jump on into integration. If I said take the derivative of the ln of x squared plus 6x. All right, so again, hopefully you're thinking du over u. This junk inside is my u. So x squared plus 6x, its derivative is 2x plus 6. So I've got du over u. All right, so if you've got that down, which I'm sure you do, that should just be some old review, let's go ahead and jump into integrating natural logs. So remember, the integral or antiderivative is the opposite of our derivative. So if I said the integral of du over u, you should be saying, who do I take the derivative of to get this answer? And hopefully you're saying, well, it's the ln of u plus c. Okay, so again, you're just thinking backwards. Who do I take the derivative of to get this answer? Now, why am I using these absolute value bars? Well, recall that if you think of that natural log graph, the x values are greater than 0. Okay, so I'm just implying that if my x values are greater than 0, I should have a positive value, hence the absolute value bars. All right, question 1. The integral of 2 over x dx. All right, I'm going to start by rewriting this and pulling out the number 2. So I'm going to say this is 2 integral 1 over x dx. Okay, and again, hopefully that 1 over x jumps out you as the ln of x. So this is really just 2 ln, the absolute value of x, plus c. Okay, so 1 over x is my ln of x, du over u is my ln of u. Question 2. The integral of 1 over 4x minus 1 dx. Now, this one isn't as super obvious that you're staring at an ln logarithm right off the bat. So, I asked myself, do I know whose derivative this is? Well, of course not, so I'm going to do a simple u sub. In this case, I'm going to set my denominator equal to u. When I have a fraction, it's pretty helpful if you pick the whole denominator. So I get du equals 4 dx, du over 4 equals dx. All right, so then again, that was my u. Here comes the substitution. The more shortcuts we take, the more mistakes we're making, so, take your time. I've got du over 4. So again, I'm going to pull out that fraction, hopefully you see, of 1/4. So I'm just integrating du over u. So again, I just took this fraction 1/4, pulled it out, my du's on top, my u's on the bottom, and I should get 1/4 the ln of the absolute value of u plus c. Okay, so du over u becomes that ln, like 1 over x. And lastly, I just want to make sure I substitute my original back in. A couple of us got bit by that on the fun quiz. My original u was 4x minus 1 plus c. And I've got my answer there. It looks a lot uglier. That answer just looks ugly, but the math behind it wasn't too bad. I hope you'll agree. All right, we're just going to keep chugging, and let's try another one. I've got the integral of x plus 1 over x squared plus 2x dx. Okay, so again, I'm going to go a basic u sub when I don't know whose derivative that is. And, fractions, if you want to make a note to yourself there, when you see fractions, the denominator is probably the most useful to pick. Now, if the denominator doesn't work, obviously I would try the numerator. But, make a note to yourself there. Start with the denominator. Okay, du equals 2x plus 2 dx, du over 2x plus 2. All right, so we took care of our u, do the substitution. I've got x plus 1 over u, du over 2x plus 2. Now, don't get too freaked out that you don't see something canceling. This is not tricky u-sub by any means. Just, you got to keep saying to yourself, think like an 8th grader. Think basic algebra. What could you do to this term? Okay, hopefully you're saying pull out a 2. So I'm going to rewrite that as x plus 1 u, du, 2, and x plus 1. Now, very easily, these are going to cancel. Okay, so think basic algebra first. And I'm going to pull out a 1/2, and remember it's a half because the 2 is on the bottom, du over u, and I get 1/2 ln the absolute value of u plus c. And again, I'm just going to substitute that original u back in. So 1/2 ln, oops, my u was x squared plus 2x plus c. All right, I'm kind of assuming you've got this down by now, so pause it, try this one on your own, and then check back with my answer in a few minutes. All right, well, there you have mine. If you've got the right answer, good for you. If not, try to follow my work. I picked my u, my du, the 1/3 pulled out front, and then I just integrated. Du over u gets you that ln again. I've got just a few more. So let me dive into number 5 here. Let's say integral e to the negative x over 1 plus e to the negative x dx. Now, some people are going to want to grab the exponent as the u because that's what we did when we had exponentials. We said, okay, let the exponent be your u. Now, I think you can kind of do that mentally. If I let my exponent be my u, if I said u is equal to negative x, its derivative is just negative 1. And is that useful in canceling with anything? Hopefully you're saying no. So again, when you have a fraction, I would start by picking the entire denominator. So I'm going to use my u as 1 plus e to the negative x. Okay, pick that whole denominator. Carefully take your derivative. Watch your derivatives for ease. So again, the derivative of 1, that constant should be 0, e to the negative x times the exponent, so times the negative, and then I'll solve there. So I've got e to the negative x over u, du over negative e to the negative x. Then these will obviously cancel, and just be careful that you pull out a negative. You've got your du over u, which of course is negative ln of 1 plus e to the negative x plus c. Now, I just want to be clear, the multiple choice can get a little sneaky at this point. You've got to be smart about your natural log rules. Remember, you could take this negative and move it up to the exponent. So just be careful. If you don't see your answer right away, you're most likely not wrong. You're just going to have to play around with your answer to make it look like one of theirs. All right, so like I said, I just have one last one for us, so hopefully you've got some great notes for class tomorrow. And I'm sure someone will pick on me, I think this is example 6. Let's say e to the x plus e to the negative x all over e to the x minus e to the negative x dx. Okay. So again, in the fraction, try picking the entire denominator. So try the u-sub on your own. Again, pause it, check back with me, and see how you did. So I've got my u over here. Be real careful with that derivative of the exponent. Make sure you bring that negative down and make that a positive. These should cancel real nicely, and I'm really just integrating that du over u. So I get my ln of e to the x minus e to the negative x plus c. Well, hopefully that didn't go too shabby for you, and we'll have lots to practice tomorrow. Look forward to seeing you then. Have a great night.